Problem number 1. The following data were recorded during the tensile test of a 14 mm diameter mild steel rod. The gauge length was 50 mm. So, nakikita natin dito, we have here the data of the load with the corresponding elongation or deformation. So, we are asked to plot the stress-strain diagram and determine the following mechanical properties. First is the proportional limit. Second, the modulus of elasticity. Third, the yield point. Fourth, the ultimate strength. And the rupture strength. So what we are going to do is to determine the stress and the strain from the given data. So we have here from the given data, so given yung load and the corresponding elongation. So we are going to compute for the stress and the strain for the corresponding load and elongation. So if we are going to recall the formula for the stress, we have the stress is equal to force over area. So given here is the force, the load here is your P. And yung area natin ay makukuha natin from the given. So kung babalikan natin yung given natin, we have and the length of 50 mm. So, yung mga given natin, we have diameter of 14 mm and the length equal to 50 mm. So, since given is the diameter, then we can now compute for the area from the diameter. Since this is equal to pi d square over 4, so the area is equal to pi multiplied by the diameter, which is 14 mm, square over 4. Then we would have the area equal to, so hindi ko naman naisama si pi sa computation, so we have 14 square over 4, and that will give us 49. So we have the area of 49 pi mm square. So since we already have the value of the P, ito yung P given here, and the A here is the area. So, gagamitan natin ang calculator and our equation would be force over area. So, si force papalitan natin ng X. And the area is 49 pi. So, yung X na ipapasok natin dito would be the value of the loads. So, here, if X is 0, we know that the stress would be 0. And if X is 6,310, so we have 6,310, so we have here calc 6,310, and that is equal to 40.99. So we would have here 40.99 megapascal, and this is 40.99 megapascal. Now, if the load is 12,600, so calc 12,600, and that is equal to 81.85 megapascal. If this is 18,800, so we have calc 18,800, and we have here 122.13 megapascal. For 25,100, so we have calc 25,100, and that is 163.05. Iko-compute lang natin ng dire-diretso, and then later isusulat ko lang isa. And for 31,300, so calc 31,300, and that is 203.33. Calc 37,900, and we have 246.2. So, ito na yung mga values ng stress na na-compute natin. And if we are going to compute for the strain, we know that the strain is equal to the change in length over the original length. Since we have here given is the elongation, so ito yung elongation and yung delta natin, and L is 50 mm. So we have here let X is the deformation and L is 50. So we know that if the elongation is 0, therefore the strain is 0. So itong column na to ang ipapasok natin sa calculator. So compute muna natin, tapos later ko na lang isulat yung sagot. So for calc 0.01, and we have 2 times 10 to the negative 4. We have calc 0.02, and that is equal to 4 times 10 to the negative 4. Calc 0.03, and that is 6 exponent of negative 4. Calc 0.06, and that would give us 1.2 exponent of negative 3. Calc 0.163, and we have here 3.26 exponent of negative 3. Calc 0.433, and we have 8.66 exponent of negative 3. Calc 1.25, and we have here 0.025. Calc 2.5, and we have here 0.05. Calc 4.5, and we have here 0.09. Calc 7.5, and we have here 0.15. Calc 12.5, and we have here 0.25. Calc 15.5, and we have here 0.31. Calc 20, and we have here 0.4. So what if we are going to compute for the values starting from this point, starting from this up to this point? As you can see, constant yung elongation natin with an increment of 0.01. So gagawin lang natin ay gagamitin natin yung mode, then table, that's 7, and we input the equation, so that's x, the elongation, over the length of 50. So, and we start with 0, and we end at 0.06 with an increment of 0.01. So when you hit equal, then makikita na agad natin yung mga sagot natin dito. So for 0.1, that is 2 exponent of negative 4. 0.2, that is 4 exponent of negative 4. Sa 0.3, that's 6 exponent of negative 4. And sa 0.4, that's 8 exponent of negative 4. Sa 0.5, that's 1 exponent of negative 3. And we have here for 0.6, that's 1.2 exponent of negative 3. Okay, so ito na yung mga sagot natin for the strain. Since you already have the value of the stress and the strain, and we are asked to find the proportional limit, the modulus of elasticity, yield point, ultimate strength, and the rupture strength. So dito, ginamitan ko siya ng Excel para mag-graph ko yung stress-strain diagram natin from the given data. So next thing na gagawin natin is we compute for the slope. So, dito kasi natin makikita yung behavior ng stress strain diagram natin. So, for this, we have 0. This E here is the slope at the proportional limit. So, kailangan makita natin dito yung behavior ng slope. So, stress over strain, yun yung slope natin. So, that's stress over strain. So, we have here 204 380.02 divided by 0.09, and that is equal to 4222.44. For 1.74 divided by 0.15, and that is equal to 2944.93. $383.27 divided by 0.25, and that is equal to 1533.08. For 40.44 divided by 0.31, and that is equal to 1420.77. For 22.25 divided by 0.4, and that is equal to 1055.63. If we are going to recheck, so makikita natin dito yung trend ng slope. But if we are going to recheck, masyadong mababa yung slope niya dito, no? So you have just 20,000 here. So i-check natin yung strain. Since we have 0.06, so 0.06 divided by the length of 50, and that is 0.0012. So kulang ako ng isang 0 dito. So if we are going to recompute, we have 246.2 divide 0.0012, and that is equal to 205,166.67. Okay, so kung mapapansin natin dito, we have the slope of, in terms of 1,000, ha? So we have 204, 203, 205, tapos biglang nag-78 na lang siya. So makikita din natin dito that the elongation is constant, no, from this point hanggang makarating ka ng 0.06. So ibig sabihin, this value here, no, is the value of the proportional limit. So that is equal to 246.2 megapascal. And kung makikita natin dito, nag-change na yung slope niya pagdating dito, naging 78, and this 78 here is the value of your elastic limit. And the next one is the value of the yield point, that is equal to 270.24. And the ultimate strength, so titingnan natin sa data natin sa stress, yung highest na data natin is the 441. So this is the ultimate strength. And the rupture strength is the load, is the stress at failure. So this is the rupture strength. So this is the answer for A, 246.2 megapascal. And letter B, since we are asked to compute for the modulus of elasticity, so modulus of elasticity is the slope at the proportional limit. So ito ngayon yung value. ng modulus of elasticity natin. And this is the value of the E. Since that is 205,166.67, the unit of this is megapascal. Now, if we are going to express this in gigapascal, divide it by 1,000, so we can say that modulus of elasticity E is equal to 205.2 gigapascal. And this is the answer for the part B. So, part C, ang tinatanong sa atin doon is the yield point. So, this is the answer for the yield point. This is the answer for the ultimate strength. And this is the answer for the rupture strength. Now, itong problem na to ay sinolve ko din gamit yung Excel. So, ito naman yung ginamitan ko ng Excel sa pag-compute. And, kung pansinin natin yung slope niya. So, we have here, that is the slope na hindi naman na magkakalapit. So, that is 204, 203, 205. And here, corresponding to this is the proportional limit. So the stress at that point is 246.2 megapascal. We have here the next point is the elastic limit, that's 260.49 megapascal, and the yield point is 270.24 megapascal. Ultimate strength is 441.74 megapascal, and the rupture strength of 399.51 megapascal. Now, for the value of the modulus of elasticity, it is the slope at the proportional limit that is equal to 205,169.1 megapascal or equal to 205.2 gigapascal. So if you want to have access on this Excel file, you may check the description of this video, and I posted there the link of this Excel file.